Now let us move to the next question, that is question number 21. An electromagnetic wave is propagating in a medium with a velocity v equals to v I cap. Along the x-axis it is moving. The instantaneous oscillating electric field of this electromagnetic wave is along y-axis. The electric field vector is along y-axis. Then the direction of oscillating magnetic field of the EM wave will be along. This is a quite simple question. We know the electric field vector and magnetic field vector are perpendicular to each other. If electric field vector is in y-axis, the magnetic field vector has to be in what? Z-axis, because the direction of velocity is already in the x-axis. We can solve this equation very easily if you know a basic formula from the chapter electromagnetic waves, and the formula says E cross B is equals to V. So V along I cap, that is x-axis, E along J cap, that is z-axis, it's y-axis, and therefore your magnetic field B will be vibrating along z-axis, that is k cap. If I write down nicely, it will be k cap, so along z-axis, right? So if you see the option, which one will be the correct answer? The correct answer will be along positive z-axis, that is option number 3. So option 3 is the correct answer. So I can click on option 3. This is the correct answer. Fine. So this is how we can solve question number 21. Now let us move to the next question, that is question number 22. The magnetic potential energy stored in a certain inductor is 25 millijoule. When the current in the inductor is 60 milliampere, the inductor is of inductance is. You need to calculate the inductance where options is applied to you. Read the question properly. The magnetic potential energy is given, which is 25 millijoule, right? You can convert it into joule as 10 to the power minus 3 when the current in the inductor is again 60 milliampere. It will be 60 into 10 to the power minus 3 again. Now what will be the inductance? According to the formula, we know that this is again from the chapter EMI, that is electromagnetic induction. U is equal to half Li square. Very nicely you can use this formula and solve this equation. So U is given to us, right? U is already given to us, and then I is also given to us. Fine. You just need to calculate L. So what will be L? L will be equal to twice of U divided by I square. Put the values, put the value of U, put the value of I. Your final answer will come out to be 13.89 Henry, where Henry is the unit of inductance. So your 13.89. The solving part you will be doing it by yourself, putting the values. Fine. So option 4 is the correct answer. Let me click on option number 4. Right. Now let us move to the next question, that is question number 23. Question number 23, it says that a battery consists of a variable number n of identical cell. Identical cell means all of them will have the same EMF, having internal resistance R each, which are connected in series. The terminal of the battery are short circuited and the current I is measured. Okay, which of the graphs shown the correct relation between I and N? So the graph is not there on the screen because this is a quite big question, right? So we will take the graph in the next step. So these are the options applied to you. If you see option number 1, it's been printed wrongly. Option number 1 has to be in this way. It's a straight line out here. Other one is showing that the current I is varying with N. This one is also current I is varying with N. This one is current I is varying with N. But option number 1 is current I is not varying with N. Why? The reason is, we know I is equals to N EMF divided by N of internal resistance R. Now see, if I cancel N and N, my option will be left out with we have current I will be equal to now EMF by the internal resistance R. But see, I is dependent on the EMF and the internal resistance. It is not dependent on N. So, with the value of N increases, I remain constant. So, this option 1 will be your correct answer. This graph shows that I remain constant with the variation of N. Other one is not the correct answer. So, I will choose option number 1. Right? Now, let us move to the next question. Question number 24, it says a set of n equal resistors of value R, each are connected in series to a battery of EMF E and internal resistance capital R. The current drawn is I. Now, the n resistors are connected in parallel to the same battery. Then the current drawn from the battery becomes 10 of I. The value of n is, see, this is a questions from the chapter current electricity, where if you know one formula you can solve the whole question. I will give you the formula and the answer, you need to apply that formula and do it. Okay. The formula is current I is equals to E divided by NR plus, as internal resistance they are saying capital R, right. So, if you use this formula, your value of N is coming out to be 10. The answer will be 10. So, I can click on 10, but you have to solve it by yourself. The application part I have shown you, just you need to put values, right. Now, let us move to the next question, that is question number 25. A carbon resistor of 47 plus 4.7 kilo ohm is to be marked with rings of different color for its identification. The color code sequence will be, what will be the color code sequence? By looking at the number only you have to identify. Now, let us see what will be the color code combination. So, for this one you need to know one more thing, that is also from the chapter current. The combination can be found out with a very important tricks which we use is B Roy, Great Britain, very good wife. If you use this one, you can find out B0, 1, red 2, orange 3, yellow 4, green 5, 6, 7, 8, 9. Okay. Now, you see in the question 4, 7 is given. 4 is what? Yellow. The first combination will be yellow. And then we have 7. 7 is what? Violet. So, it will be violet. Then we do 10 to the power of the number. So, next what we have? Orange, if you take orange is 3 and then plus minus of tolerance, that is 10%. If you solve this one, your answer will come out to be option number 3, yellow, violet, orange and silver. So, this is the correct answer, option number 3, right. Now, let us move to the next question, that is question number 26. Question number 26, it says that a tuning fork is used to produce resonance in a glass tube. The length of the air column is in the tube can be adjusted by a variable piston. At room temperature of 27 degrees Celsius, two successive resonances are produced at 20 centimeter and 73 centimeter of column length. If the frequency of the tuning fork is 320 Hz, the velocity of the sound in air at 27 degrees Celsius is given by. Here, lot of temperature values are given, but we will be using a very simple formula to find out the answer. Question number 26 can be solved, my dear, with this one. Velocity V can be written as twice of the frequency L2 minus L1. So, L2 is given to you, L1 is also given in the question, frequency which you also know. So, after calculating, your final answer will be 339 meter per second. So, I have shown you the application, the remaining the calculation you have to do it by yourself. Let us now move to the next question, that is question number 27. The electrostatic force between the metal plates of an isolated parallel plate capacitor C having a charge Q and area is. what will be the electrostatic force? We know between the capacitor, between the plate of the capacitor, the electrostatic force is given by Q square twice of the area multiplied with epsilon naught. So read the options now. Independent of the distance between the plates, not required. Yes, option 1 is the correct. Proportional to the square root of the distance between the plate, it is required. And linearly proportional to the distance between the plate, also required. Inversely proportional to the distance between the plate. So number 1 is the correct answer. It is the independent of the distance between the plates. So I can click on option number 1. Now this is a question from the chapter Electrostatic Potential. If you read that chapter, you will be able to answer in a fraction of a second. Now let us move to the next question, that is question number 28. An electron falls from rest. An electron falls from rest, that means U equals to 0. Through a vertical distance of h, the distance s is given to be h, in a uniform and vertically upward directed electric field E. The direction of electric field is now reversed, keeping the magnitude the same. The magnitude is same, the electric field direction is just changed. A proton is allowed to fall from rest in it through the same vertical distance h. The time of fall of the electron in comparison to the time of fall of the proton is. How you are going to calculate the time? So here you have to use the equation of motion, that is S equal to ut plus half at square, where your S is equal to h, u is equals to 0 plus half. In place of a, we are going to write down what? Ma is equals to QE, Newtonian physics with the electric field force. So your A will be equals to QE by M. So it will be QE by M T square. Now if you look at the equation very nicely, you are going to get H will be equal to QE by twice M T square. Hence T square, therefore T square is proportional to mass M, or I can say T square is proportional to root over of mass M. So what will be the time of the fall of the electron? Which one will have less? Because whose mass is, you have to know, electron mass is lesser than that of the what? Proton, right? So your answer will be number 1, that is smaller. Fine. Question number 29. A pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of the pendulum is given to be 20 meter per second square at a distance of 5 meter from the mean position. The time period of the oscillation is, you need to calculate the time period where the acceleration is given to you. This is from the chapter Simple Harmonic Motion, where you have to use the formula for acceleration. As we know, acceleration is equals to what? A is equals to, taking the magnitude only, omega square y. Acceleration is known to you. It is given 20. And omega square y is given 5. So your omega will be equals to 2. So you calculated omega. Now time period is simple. 2 pi by omega. Now time period will be 2 pi by 2. 2 to get cancelled. Final answer is pi second. So if you see here in the option, it's very close to this one. See, such a coincidence, we're getting the answer in this close path, right? So pi second is the right answer. Question number 30. The power radiated by a black body is P and it radiates maximum energy at wavelength lambda naught. If the temperature of the black body is now changed so that it radiates maximum energy at wavelength 3/4 of lambda naught, which was initially, the power radiated by it becomes Np. The value of N is how much, that is what we have to calculate. So you need to use one formula out here. The formula is lambda max multiplied with T is equal to constant. I hope you remember this formula. This is called as Wien's law. Wien's law, right? So what you will do, lambda max 1 T1 will be equal to lambda max 2 is equals to T2. Just equate this two. Once you equate this two, you will see that your answer of this question is coming out to be 256 by 81. This is the correct answer. So number 30, option 2 is the correct answer. You need to apply Wien's law in this question, then only the answer will come. Now let us move to the next question. Question number 31. Two wires are made of the same material and have the same volume. The first wire has cross-sectional area A and the second wire has cross-sectional area 3A. Okay? If the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? Okay, if you look at the question, this is from the question chapter Mechanical Properties of Solids, where you have to use Young's modulus of elasticity. If you know Young's modulus of elasticity, you can solve it. Okay, now how you are going to do it, my dear? So, if you can see, at first the wire, we have taken two wire 1 and let us do another wire 2. Saying that two wires made of the same material have the same volume. The first wire has cross-sectional area A and the second wire has cross-sectional area 3A. This one has cross-sectional area 3A and this one has cross-sectional area A. Now imagine if this is 3A, if area is decreased, the length will increase. If I start stretching it, yes or no, the length will increase. So its length will become 3L, where the length of this one will remain L. Okay, they are inversely proportional to each other. Now what you need to do is, you need to apply the formula from the chapter, which is what? Young's modulus of elasticity is nothing but stress by strain. So force by area and delta L by L. So you need to calculate delta L. So your delta L will be equals to F by A divided by Y multiplied with L. In the first case, you put L as 3L, and in the second case you put L as L but area as 3A. Okay, this will be your first case, and then make another one. Put it equation number 1. For this one it will be 3L, and the for second one, that is delta L by L, delta L dash, let us consider FL divided by thrice A into Y. Put it equation number 2. If you take the ratio of equation 1 and 2, you will see that your answer is coming out to be 9F. So option 1 is the correct answer. I hope this is clear with you. Now let us move to the next question, that is question number 32. A small sphere of radius r falls from rest in a viscous fluid. As a result, heat is produced due to viscous force. The rate of production of heat from the sphere attains its terminal velocity, which is proportional to. Okay, you need to use the formula again. This is from the chapter Mechanical Properties of Fluids. If you know that chapter thoroughly, you can solve it. It says 6 pi eta r Vt square, right? So if you see, it's directly proportional to r multiplied with r square of square. So directly proportional to r to the power 5. So your final answer for this question is coming out to be r to the power 5. You have to see the chapter Mechanical Properties of Liquids, and then you will get the procedure and the applications very nicely.